what is meant by a declaration? A declaration associates an identifier with the type, and it can introduce a variable, function, or a type. So let's look at this, because the other ones are very well known. When we declare a type, we use typedef. Well, we can also create a struct, but that's not an identifier. I mean, the struct tag is not an identifier, although it looks exactly like one. Okay? And the type here, when we use this integer, it's called a typedef name. We will come back to that very soon. Okay, so we can also declare, instead of using 3 different lines, we can put them all on the same line. And note that we need 1 star for each of these. And I will explain soon why, namely now. Okay, so this is called, well, here we have a declaration, and a declaration consists of a type, like this, and a sequence of declarators. And here we have 1 declarator. Okay, so the star and array and function, they are part of the declarator and not part of this type. Of course, the type is called a pointer, but when we parse it, it is, so to speak, owned by the identifier. Or another word, associated only with 1 identifier. That means here we have 3 declarators, and the first one is this, and the second and the third. Okay, and that means the B and C, they are not pointers. And why is it like that? Well, it is how Dennis Ritchie created the C language in the early 1970s. And it's just to accept that this is a nice way to create a language. It's exactly the same in C++, of course. Okay, we can also make a comment about this. It's quite uncommon to make a declaration with both a plain int and a function and an array. This is should probably not be used, because when somebody sees this, it's perfect valid C. But when somebody sees this, they will be a bit surprised. And so usually we put the functions on separate declarations, but they can be distinct declarators in the same declaration as here. Okay, namespaces, it's where different types or kinds of identifiers belong. So we have variables, types, I mean typedef names, and functions, they belong to one namespace, and struct tags belong to a different. So let's see what happens if we now create a type, and then we use this type with a variable. We get compilation error, because A is already used in this namespace for this. Actually, this is a quite interesting thing. How is this parsed by a C compiler? Well, first, this is a reserved word or keyword, so it's parsed like that. I mean, the lexical analyzer says, now I found a typedef, so-called token, and then it says it found an int, and then well, let's just say it found an identifier. Okay, and then here, what is this? Is it an identifier or something else? Well, the token is called, usually it can be called anything, but usually it's called typedef name. I mean this. So the lexical analyzer says it found a typedef name, and then it found an identifier. So how can the lexical analyzer know that here it should be an ID and here it should be a typedef name? The lexical analyzer just sees the characters. Okay, so what happens is that it must ask what the parser, which looks at the grammar, expects. And if it prefers a typedef name or if it prefers an identifier. So this is a little bit complication in parsing C and C++. But C++ parsing that is almost infinitely more complicated than parsing C. This is the only thing that's complicated in parsing C. Okay. What we more can see is that we can have different identifiers, different names for this. When I say name, I mean informally, so it can either be a tag or an identifier. Okay, and we can also use the same for all of them, since that S and that S belong to different namespaces. Okay, there is another thing that we have not introduced already, but it's called a label, and that is it can be used as follows: that we write goto and the name, and then the program will jump there. Usually we don't use it just to jump to the next statement, but, well, never actually, but goto has somewhat bad reputation because it's easy to make a program that is completely incomprehensible, and that's called a spaghetti program. Goto are fine to use if they are done in a systematic way, such as using goto and to the end of a function. That's fine. In the 1960s there was a big debate, or maybe it was in the early 70s or complete 70s, there was a big debate about the bad thing about using goto. And some said it should be forbidden completely, and others said, okay, use it in a nicer way. But it is quite fine to use, but maybe try different solutions first, other solutions first, but it can be good.